Yes, that's all good. Exam pressure.
Hmm?
Yes, that's Alan. Why are you sounding so low? All okay?
Oh, yes, sir. Yes, sir.
Chill, chill, dude.
Yes, sir.
Okay. So these
Let's
were
scroll
the
down.
yeah, these were the things that we did in the class. And Aisha, have you started revising all those chapters? Yes, Aisha, have you
Yes, sir.
started?
Scroll down.
Okay, good, good. Yeah, because otherwise, at the last moment when you start, then you'll have a lot of powers.
Let's scroll down.
It's done. Done.
Yes, sir. Scroll down.
Yeah. So then we were talking about this couple, and after that, the time got. I'll talk about this in the next class, right? But we need to just remember that whenever equal forces are acting in opposite direction, so there is a translation equilibrium, but there is a rotational thing which is happening. So that gives the torque, right? So these were the things that we did, and I was talking about this thing. So please revise this force on a charged particle in external field, and we will talk about this torque on a diamond. So this we do tomorrow. And Aisha, if you want to
Sir,
join
a
that,
little up, please.
yeah, Aisha, if you want to join that part, you can also come, right? Yeah. So done.
Yes, sir. Done.
Then we will talk about, and this chapter is I don't know. We are stuck in this chapter for a long time. This chapter is taking a lot of. Okay, so now let us. Yeah, we talked about this prism. Now let us talk about this microscope, right? Which we wanted to do for a long. Why this is working so slow? Yeah. So now in this part, we'll talk about optical instruments, right? And specifically, we will talk about two instruments. One is microscope, right? And in microscope, we will talk about two things, which is simple microscope and compound microscope, right? And then we have this telescope that we talk about. So, what are the optical instruments? So, optical instruments are those devices which uses the property of light's reflection or reflection through lenses to do some other jobs, right? So, they have some specific purposes. For example, we have this microscope, so which is used to magnify the very small objects near to us, right? So that is the use of this microscope. So I will not write those definitions. You guys already know those definitions. So first thing that we will talk about that the natural microscope that we have is our human eye, right? So if I want to zoom this thing, okay, let's say I have what is the smallest thing. So I cannot pluck my hair and show you guys. Let's say that a very small thing. I, so let's say something which is written in this right, and let's say I cannot read this thing. So how do I zoom this thing? I look closely and closely, and then it will zoom out, and then it will be magnified, right, through my eye lens. So the nearest distance up to which I can see this object is what? What is that called? Nearest, nearest thing that we can place the object to see clearly in a normal eye. That is
Lens.
nearest. How much nearest you can put the object to see that object clearly. Let's say if I put this object in here, so can I see that object? No, right? If I put this object, I have to place at some distance. So the nearest that I can see the object clearly is the near point, right?
Yes, sir.
So with our human eye, we can clearly see the object at near point, right? So let's say this let's say this is our eye, which is looking at theta naught, and this is the object side, and this is so with normal eye, right? So nearest way we can see this object is this near point. So this is our eye, and this is the near point n, and this distance is called t, right? So tan theta naught would be how much? That would be h by t, right? We are not using any lenses, so we are not using any sign convention, right? We are not using any lenses, so we are not using any sign convention. So this is the nearest that we can see the object, right? And this is the magnification for that case. So this is the theta naught. And let's say this angle is very small, so I can write tan theta naught as nearly equal to theta naught. So this theta naught would be h by t. So please remember this thing. We will use this thing in some other form, right? Okay, so now I want to again magnify this object further, right? Because let's say if I have some hair strands, if I have some amoeba, if I have something else which is very small, and if even if I could, even if I can put this object at my near point, and I cannot see that object clearly, so then I'll have to use this other means. And the simplest thing that we can do is use a convex lens, right? So that thing is called a simple microscope, right? So we know that when we place the object, when we place the object between the focus and the optical center, right? So then the object is magnified. So we'll use that property of the convex lens, and we will use that in there. So it is a device which uses a single convex lens to magnify, because that is the ultimate goal, right? Magnify the object. Okay. So the idea is that we place this object between, idea is what? Place the object between focus and optical center of the lens. Right. So then working and construction is what? So we have this lens, right? And this is, let's say, this is optical center. This is our focus, right? And we place this object in here. So this is a small object. I have zooming this object. So this is a small object, right? Maybe let's say this height. So this is the object. And if it falls on this thing, so where this object will go through. So from where this object will go, it will go through this point, right? From our focus, right? And we have this optical center, right? So this is, I should draw it like so that I get a clear. So let's say this is the focus. Okay. So you can see that these rays are diverging. So will they meet in this side? Will they meet in this side?
So which side?
In the right hand side. Will they meet? These rays will meet at some point.
No, sir.
No,
Because
right. So which means that we have to elongate this ray in the left hand side, right? So if we elongate this object in left hand side, so it will be in here, right? This is merging. But, and where should I put this? Where should I get this object? Where can I see this object clearly? So this should be the near point, right? This should be the near point so that I can get a clear image. So this is my simple microscope, and I have so this is my eye, right? And I'm looking this thing. So I will see this object. So this is my object. This is a small object, but it will be magnified, right, guys? So this will be magnified. And I will arrange this lens in such a way that I get this image at near point, right? So this is my near point. So this is the idea of simple microscope, right? I will get a magnified object. So this object was very small, but I will get a magnified object. Is this thing clear, everyone? Is this thing
yes, sir.
okay? So now I know that what is the lens equation? Lens equation from lens equation, right? This is my U, okay? This is my V, right? And F is in this side. So this is my F. So using from lens equation, what we will get? We have 1 by V minus 1 by U, that is 1 by F, right? And you guys know that what is the magnification? Magnification is what? For lens, what is the magnification? Yes, guys. For lens, what is the magnification? Magnification is how you can, how much enlarged you are seeing the object, right? That is from height of the object, this is h prime by h, or from image and object distance, this is this. This is the magnification that you have already studied, right? These things we have already studied. So this is our h prime and this is our h. So any confusion up to this point, guys? This is already, these things we guys have already done.
Yes, sir, no doubt.
Yeah. So now you see that I want to, let's say, I want to calculate 1 by u. This would be how much? If I take this 1 by v in other side, so this is 1 by f minus 1 by v. And this is negative sign, this goes over right hand side, so this will become 1 by f. And let me write it properly, so this will become 1 by v and minus 1 by f. So this negative sign will come in this side and this will be this. So this will become positive, this will become negative. So this is positive, this is negative. Now for magnification, I need v by u. So in the denominator, I should have u and in the numerator, I should have v. So what should I multiply in this equation so that I get v? What should I do? Yes, guys, what should I do so that I get v by u? Yes, guys, what should I do?
Mm,
In the numerator,
sir,
yeah,
uh, what are we supposed to do in this? I didn't understand.
we are trying to calculate magnification. For
Yes, sir.
magnification, it is defined as v by u, right? So
Yes, sir.
1 by u is there and I want to get v by u. So what should I do with these equations so that I get v by u? That is the idea, right? Ultimately, I want to calculate v by u, which is magnification. So I will multiply this equation by v. Clear?
Yes, sir.
So I will get v by u. This would be v by v minus v by f, right? So v by u is magnification, right? This is v by v, so 1 minus v by f. So this is the magnification that I will get. And remember, this is specifically called a linear magnification. Okay, so so you see that where my image is forming, my image is forming at the near point D, and I'm going in the left hand direction. So I know that my image is minus of D, right? This is the near point. So, so what will happen if I put the value of V as minus D by F? So minus minus would become plus, so 1 plus D by. So that is how I will get the linear magnification. So this is the linear magnification, right? When object is formed at near point, right? Is this thing clear, guys? Is this thing clear? Yes.
Yes, sir.
Okay. So this is the linear magnification. But as you can see that if I look closely this image, which is forming, right? And the image is virtual and erect, right? Because not the actual rays are connecting or intersecting. The rays are intersecting when we extrapolate them, right? When we extend them. So image is virtual and erect, right? And this image is forming at the near point. So this much closer this image is forming. Although we are getting a magnified object, but it is straining our eyes, right? It is straining our eyes. So what we will do is that we will put the object at focus so that the image is formed at a very high distance, very large distance, which is we call infinity, right? Infinity is not America or something. For length, infinity would be, let's say, from Riyadh to Dubai. That is also infinity with respect to this distance, right? So infinity means very large distance. Okay. So this is straining our eyes, right? So, but the image formed at near point is straining the eyes. So we will put the object at focus, right? One of the focus of the lens. So at one of the focus of the lens, right? Then what will happen? So now if we put the object at focus, so this is one focus, right? And we have put this object at here. So these ray will go like this, and these ray will go like this. So you see that these are parallel, and we are seeing this object from here, right? So now this is not straining our eyes because the object is not forming this closure. This is not forming at this near point. This is forming at, let's say, a very large distance at infinity. This object, this image is formed, right? So can we calculate? So linear magnification would be how much? For this object, we know that V is infinity, right? Height of the object is at infinity. So what would be linear magnification? Linear magnification is V by U, right? V is infinity by U. So can we calculate the linear magnification? Can we calculate the linear magnification, guys?
No, sir, because
Right?
it's
Yeah.
infinity by you.
Yeah. So we cannot calculate the linear magnification because V is infinite. So in this case, what do we do? So in this case, we calculate angular magnification, right? So what does this name suggest? Angular magnification. What does this suggest? What does this? suggest angular magnification. Magnification is enlarging the
So
object, right?
angular magnification probably means like magnifying by through a certain angle or like at a
Yes,
certain angle.
yeah, absolutely right. So we are magnifying the angle, right? So it is magnified by some angles. So in the first case, when we didn't use this thing, so let's say this angle is theta 1, right? This is the new angle. When the object is at focus, so this is our focus, right? And this is also the U. So this is optical center. And these lines are parallel. So let's say if this is theta I or theta 1, so what would be this angle?
So
What
that
would
would
be
also be
theta
theta
1?
one, right?
Theta 1, absolutely right. And let's say the height is h prime, right? So height is h prime and v is v. So for theta 1, if I calculate tan theta 1, so that would be how much? That would be in this case, so we have to calculate angular magnification. So before we do that, we will calculate the angle. So in the previous case, what did we see? When we didn't use the lens. So this much magnified we can get the object. So this was the theta, right? This was the theta when we didn't use any lens. Now we are using the lens. So theta has become this one, right? So angular magnification would be how much? Angular magnification, this would be m and this is theta 1 by theta naught. Is this thing clear to you guys? This is how much the angle has been increased, right? Is this clear, everyone?
Yes, sir.
Okay, so now we have to find out this theta, right? We have to find out this theta 1. So we see that this theta 1 is equal to this theta 1. So we can calculate this theta 1 from here, right? So this would be how much? So this is h, right? And this is f. So this would be how much? Tan theta 1. This would be h by f, right? Is this clear? And these angles are very small, so we can write this as theta 1, which is equal to h by f. Okay. So this would be theta. And we already know, right? We already know that what is, theta naught, right? So let us put these values. So what we will get? And if we use the sign convention, right? So this would be minus f, right? Or if I write, this is minus f, and this is also we should write as minus, right? This is minus t. So this would become how much? So angular magnification, which is theta 1 by theta, this would be h naught by f divided by h by minus. So this will cancel, h will cancel, and this would be d by f. So angular magnification, this is d by f. What was the linear magnification? This is angular, right? What was the linear magnification? This was the linear magnification, right, guys? So which one is greater? Linear magnification or the angular magnification? Which one is greater? Which one is greater? Which one is greater, guys? Yes. Okay. Let's say one magnification is 1 plus 7 by 3. The other is 7 by 3. Which one is greater? Which one is greater? Which one is greater in these two? 1 plus 7 by 3 or 7 by 3? Which one is greater? Okay, let me simplify this. 1 plus 2 is greater or 2 is greater? Which one is greater?
And I said 1 plus 7 by 3, sir.
Right, so this one is greater and this one is greater by 1. Right?
Yes, sir.
So we see that linear magnification is 1 plus angular magnification, right? But so in a linear magnification, this is a greater magnification. We are getting an enlarged object, but this was straining our eyes. So that is why we have used this angular magnification to put a less strain in our eyes. And by doing that, we have to compromise with the magnifying power, right? So this is the all thing that we have to talk about this uh, simple microscope. So this is everything about simple microscope, right? And if we talk about magnification thing, so if we talk about magnification, let's say linear magnification, right? So we want to strain our eyes. Let's say linear magnification. So you guys have to understand, whenever the image is forming at the infinity, so we will use this angular magnification. And whenever the object is formed at this near point, then we will use this linear magnification. So these are the two things that we have to be very careful about, right? So in simple microscope, there are two types. One is that the image is at D, or the other thing is that image is at infinity. So if we use this thing, then we'll have magnification which is linear, and this is d by f. And for this case, we use angular magnification, and this is given by d by f. So magnification has been reduced by 1, but this is less straining to our eyes, right? Now the idea is that how much we can get the magnification. So how much magnification we can get? How much magnification we can get? So you guys tell me that what is the D is for a normal eye. What is the near point of a normal eye? How much is that? For a normal eye, what is the near point? How much is the near point for a normal eye? For a normal eye, how much is the how much is the near point? 25 centimeters.
25.
Yeah,
Yes, sir.
25 centimeter is the near point, right? So 25 centimeter is the near point for a normal eye. So let's say that how much magnification we can get from this simple microscope. So this is 25 Now, all depends upon what? The magnification depends upon what? Yes, magnification depends upon what? You see, linear magnification, that is 1 plus 25 by f. The magnification is depending upon
The magnification depending upon the f.
f, right? And if you want to magnify the object, so the focal length should always be less than 25 centimeter, right? If you want to magnify the object, so the focal length should be less than 25 centimeter. And you guys can see that how much closer this distance is. 25 centimeter is pretty small. But the closest focal length or shortest focal length that is physically possible is nearly, let's say, 3.5 centimeter, right? So 3.2 centimeter that we can make, right? So 3 centimeter is pretty small. You guys can imagine that. How much is 3 centimeter? So let's say, do you guys have this scale, right? Where is the sheet? How can I? So yeah, this this distance is 1 inch, right? 2.5 centimeter.
Yes, sir.
So this much length of focal length that lens should have, right? So I can or naturally or possibly, which is physically possible, that we can make a focal length which is of this much length, 2.5 centimeter or 3 centimeter. So only this much of a focal length we can do, right? We cannot make a lens which has a focal length which is less than 3 centimeter. That would be very close, right? So this is humanly impossible to make a lens whose focal length is less than 3 centimeters. So you can imagine that how much 3 centimeter is. So this 3 centimeter is pretty small, right? If you have a lens, you guys have seen the lens. So you know that the lens width is about 2 centimeters, right? So lens thickness is about 1 or 2 centimeter. And to make a lens whose focal length is less than 3 centimeters, so that is humanly impossible, right? So the largest magnification that we can get, so this is 3.2. So this is nearly 3.2, let's say. So this is nearly 8 centimeter. So this is 8. So we can get less than equal to 9 magnification. So this much of a magnification we can get from a simple microscope, right? So this simple microscope is very limited. We can only enlarge the object up to 9 times. So we can only enlarge the object 9 times, right? But if we need to study a very small very small thing, so then we cannot use this simple microscope, right? We can study the leaves or we can study those guard cells, right? So you have this biology, and you guys must have used this simple microscope. So this simple microscope has a limited use, right? We cannot magnify the object greater than 9 times. So that is why we add one more lens. So, and then we know that how the lenses give the magnification. So we know that the effective magnification is the product of the magnification, right? This thing we already know. So then we use the compounding of lenses. So we add another lens and then we magnify the object even further. So then we can get up to 40 to 1000 or maybe 1500 times. This much of magnification we can get, right? So one device is magnifying 9 times, and one device is magnifying 1500 times. So which would be easy to use, and which would be useful in studying those microorganisms? Which would be useful? Yes, the compound one, right? This one. So we talk about this compound microscope because this simple microscope has a very limited. So this can only magnify the object up to 9 times. So that was argument that I wanted to make. That why did we need this compound microscope? We have this simple microscope, then why do we need this compound microscope? So that was the purpose, to magnify the object even further, right? So what did we study? That we have a simple microscope, and we can see or magnify the object in two ways. So one is place the object or get the image at near point, so which in which we will get a linear magnification, but that will strain our eyes. And the other thing that we can do is that put the object at focus, so the image will be formed at infinity, so then we'll get the angular magnification. So these were the things that we studied in this thing. So please, if you guys have any doubts, please ask me. Otherwise, please. Is this thing clear, everyone?
Yes, sir.
So please note it down. This was the first case, right? With normal. And whenever you guys want me to scroll down, please yeah, whenever you guys want me to scroll down, please
Yes, sir.
done.
Which size? A bit more. Oops, scroll.
Yeah, so you guys please look. My diagram is very bad. You guys look the NCRT book and see. Yeah. So these diagrams are very important. So labeling and all these rays which are coming and going, these are very important, right? Whenever we are doing ray optics, so labeling those diagram and writing all the information and yeah, the incoming and outgoing rays, that is very important. So you guys got the idea that when we will use this angular magnification, when we will use this linear magnification. If we want to have less straining image, then we use angular, and if we want to have
Okay, so scroll.
right? Multiply by v in equation.
Yes, I scroll down.
Yes, whenever you guys have noted it down, please add it. Yes, done everyone.
Yes, sir.
Okay, then please name down these things. Yes, whenever you guys have noted it, please tell.
Yes, sir. Scroll down.
Yeah, so these are the things that so these are the things just to tell you that how much magnification we can get from a linear from a simple microscope, right?
Sir, scroll a bit up. I missed one line. Oh, yes, sir. This one, this one. Okay, sir. Done, done.
Yeah, so this is just to show you guys that how much magnification we can get from a simple microscope, right? So now let us quickly start this compound microscope. Okay, you guys just understand this part. Yeah, just remember this thing that the highest magnification that we can get is 9 times, right? Because this much of a small focal length we can make physically possible, and this will give you this much amount of magnification. The next topic is compound. So the maximum magnification that a simple microscope can provide is 9 times. So to study objects which require a higher magnification than this, we use compound microscope. So what does it do? So it uses two lenses multiply individual magnification of two lenses. So the effective magnification becomes the multiplication of magnification of right. So this is what these compound microscope does, and we already know that it has two lenses, right? So there are specific names of those lenses. One which is nearer to object is called objective lens, and one which is nearer eye is called eyepiece. Right, so we have two lenses. One is objective lens, and the other one is eyepiece. So objective lens has a small aperture, right? You guys can write all these things in the exam, but the important thing that is with the important thing is the construction and working, right? So working and construction. We have a lens. This is near to the object, and we have first I will make the diagram, because it always happens that so now it is here, and then this is I. My drawing is pretty bad. So you guys can see that this will form in right, somewhere somewhere, and this is what. So from here to here, this would be the near point. This is the D, and this would be what? So this is coming parallelly, right? So this would be how much? This would be focus. So from here to here, this is the focal, right? And let's say this is, so this one, these two things are cutting at intersecting at this point. So what is this thing? What is this thing, guys? Yes, these two rays are going through this lens and cutting at this point, intersecting at this point. So what is this thing? This is the real object made from this thing, right? This is the real object, real image of this object at this place. But I fix this place in such a way that I fix this length. So I increase or decrease this distance in such a way that this distance is near to the focal length. Right. So this is not exactly, but near to the focal length of this. So from here to here, this is focal length of the eyepiece. Right. So this is focal length of the eyepiece. This is focal length of this objective lens, and you see that this is the distance between the focal length, right? This is called L, length of the tube. Okay, and let's say this angle is alpha. This angle is also alpha. So this one is objective lens. This one is the eyepiece, and the final image that we are getting. So you guys can see that how much enlarged this object is. So let's say this is H, this is H prime, and this is H double prime. Okay, and we know that this would also be H. What would be the angular magnification at this point, right? So what is the angular magnification at so how much is that? So tan alpha is how much? This is H by F, right? Tan alpha is H by F, and we know that this is FO, right? And we also know that what is this tan alpha from here. This is equal. This length is L, right? This length is L. This is H prime. So this would be how much? Tan alpha would also be H prime by this L. So tan alpha is also H prime by this L. So we will get H prime by L, that is H by F now. So if we calculate H prime by H, this is L by F. So this is the magnification, right? This is the magnification by objective lens, right? And we already know from simple microscope that if you put the object near the focal length, right? If you put the object near the focal length, then what is the magnification? So for eyepiece magnification is how much? So this is MO, right? Magnification of the object lens. This is the 1 plus D by F. We will directly use that. So for eyepiece, this is the magnification. For objective lens, this is the magnification. And we know that effective magnification is how much? That is M1 into M2, which would be MO and ME. So M, effective magnification, this is how much? This is L by F naught into 1 plus D by F. But if I want to get the image at infinity, right? If I want to get the object or the image at infinity, so I don't want the object at image at here. I want the image at infinity. So this would become how much? This would become how much? At infinity, this ME would be how much, guys? Yes, we have already seen in the simple microscope. We have already seen this in simple microscope. The linear magnification becomes angular magnification and this one is gone. So this is D by FE, right? So at when the image is at infinity. So magnification would be how much? L by F naught and D by F. So you guys can see that the magnification is depending upon what are the things that the magnification is depending upon. What are the things that the magnification is depending upon, guys?
Sir,
Yeah, D we know that is 25 centimeter, right? So magnification is depending upon L, it is depending upon FO, and it is depending upon F. So we can increase or decrease the size of the magnification depending upon the different focal length of these F and E. And we can also change, so let's say if we increase this tube length, right, where these two lenses are placed. So you guys have seen the image of the microscope, right? Let me show you guys the image of the compound microscope. So, so you guys can see that. Yes, you guys can. Oh, is this visible? Yeah, this is right. So in here at the top, the eyepiece is there, and in here you have this objective lens, right? So
yes, yes.
if you increase this tube length, if you increase this tube length distance between the eyepiece and this objective lens, then you can get a larger magnification, right? So in the simple microscope, we had only one thing to work upon, right? In simple microscope, we had only one thing. And what was that thing? We can only make the lens in such a way that that had a small focal length. So only this was the thing that we can work upon, right? Only the focal length. But for the case of the compound microscope, you guys can see that we have three parameters which we can modify. We can modify the objective, the focal length of the objective lens. We can modify the focal length of the eyepiece, and we can also modify the separation between the lenses, right? So with these three parameters, we can get a magnification up to 1500 times, right? So the magnification of compound microscope is dependent upon this L, FO, and FE. So you can see that there in every compound microscope, there would be, so near to eyepiece, there would be sign that how much it can magnify. And similarly for the objective lens, there would be some sign that how much it can magnify. So you can change those distance and depending upon your need, you can change the magnification, and you can zoom in or zoom out of the object that you are studying. So that is the importance of this compound microscope, right? You can because in a simple microscope, the focal length is fixed, right, guys? If you have a simple microscope, the focal length is fixed. You cannot change the focal length. But in the case of compound microscope, how much magnification you need, so you can work on this tube length and you can get that. So that is the advantage of this compound microscope. So it is magnifying much larger. We can change the magnification also, and it is dependent upon three parameters which we can change. So these are the advantages of compound microscope over the simple microscopes. Are these things clear, everyone?
Yes, sir.
Okay, so then please note it down, and we will do a couple of questions, but yeah, we'll do those things later. But if you guys have any doubts, please note down. And this diagram is very important, right? So always practice this diagram. This diagram contains all the answers uh, that you want to get. So please practice this diagram, and please note it down. And if you guys have any question, please tell.
Sir, I already noted compound microscope down. Can you just go?
Oh, you already noted this thing.
Yes, sir. Yeah, it was so long. I wanted to just write it early.
Oh yeah. So you
Yes,
guys,
sir.
what
I thought
about
it
you
will
guys?
take a lot of time.
Yeah. What about you guys? Aisha, Mariam, Meet, what about you guys? Did you guys also note it down, this part?
Yes.
Oh, good. So then please, yeah, this diagram you can look in this book. And this diagram is very important, right? So the idea is that we calculate two magnification, one from here and the other one from here. So this is our objective lens, and this is our eyepiece. So you guys can see that which has a larger aperture. Which one has larger aperture? Eyepiece has a larger aperture, right? So everything is there in the diagram. When we understand this diagram, it becomes clear. So yeah, whenever you guys have looked at this part, please tell.
Yes, sir. Done.
Done. Okay, then please note down this part. So it is, this one is for
Sir, we're
yes.
coming from the washroom. I'll come back in 3-4 minutes.
Okay, so okay, please yeah. And whenever you come,
Yes, sir.
please.
Yes, I'll come back.
Yes, guys, noted. It noted. Please, Arsalan. Yeah, yes, guys, please wait for Arsalan to come and then we will move on. Okay, in the meanwhile, you guys can write. So please talk. So, have you guys used this compound microscope? So, in your lab, in your biology lab, you guys must have used this compound microscope, right? Right. So, you have this knob, and this knob changes this L, right? So, this L is changed by that knob, and then you can focus or you can focus on all the things that you do. So, what the working idea is this, right? So you can calculate the magnification by just calculating this. And yeah, so very- okay. So in the next class, I will start. I will also start this wave optics because because only telescope is remaining, and that will not take that much of a time because only only two kinds of telescope is there in your syllabus. So, yeah, we will study those things. Yes, noted everyone. Aisha, Mariam, did you guys note it
Yes.
down? Okay, good. So next, oh, yeah, I will just write these things down, and I will write that in telescope what we study. So in telescope there are two telescopes. One is astronomical, right, and the other one is this terrestrial. So, as you guys can understand from the word, astronomical means that whenever we study the objects which are out of surface of the Earth, right? So, whenever we are going beyond Earth, that is astronomical. Whenever we are seeing the objects which are very far from us, so let's say that I want to study some things in North America. So I am in India. I want to study some things in America, right? So then I will use this terrestrial telescope. So whenever I am studying the objects which are very far away, but they are on the Earth surface only. So that is the terrestrial telescope, and the other one is whenever we are studying the objects which are beyond the Earth, right? So this part is not there in the syllabus. We will study this astronomical telescope, and this one has also two types. One is refracting, and the other one is reflecting. These two kinds of telescope we will study, right? And this will not take that much of a time. So in the next class, when we do this, So I will also start this wave optics in the next class. Whenever we will meet, I will start this wave optics.
Yes, sir.
Okay, yeah. So you have returned. So please take a screenshot of this part. How much did you note it down? Did you note down this part?
Yes, sir. This part note down, just below this part.
Yeah, just take the screenshot. Okay, because everybody wants to. Just take the screenshot.
Yes, sir.
Done.
Okay, sir. Done.
Okay, so see you guys, Arslan and Mir. I will see you guys tomorrow. And